Hello, my name is Dalia Ramirez and I will present some results of ECA studies for the CMS iRPC detector for the high luminosity LHC. In this work, we present an analysis from unpublished data taken at CMS. This analysis was approved by the CMS collaboration. RPCs are particle detectors whose active medium is a gas mixture. CMS uses RPCs as trigger system for data acquisition. The motivation of this work is that mixtures with high GWP index are harmful to the environment, making necessary the search for alternatives with lower GWP. The actual mixture for the CMS RPC has an index of more than 1000. If particles are charged, they will interact with matter via ionization, excitation, Bremsstrahlung emission, and electron-positron annihilation. On the other hand, if they are neutrals, the interacting processes are Compton and photoelectric effects and pair production. In particular, muons are one of the particles detected by RPCs. They are charged and heavier than electrons but can pass through matter almost without interaction. The blue line represents a muon passing through CMS detectors. RPCs are gaseous detectors. Here we can see a schematic view of an RPC. It consists of two highly resistive electrodes, filling gas, graphite paint coating, and two planes of conductive lines. The actual CMS system is composed by double gap camera system, 480 cameras in the barrel, 576 cameras on the outer cover. It works in avalanche mode, bakelite electrodes of 2 mm thick, 2 mm gaps, and a relative humidity between 40 and 50%. The CMS gas mixture is composed of 4.5% isobutane, 0.3% SF6, and 95.2% freon. Data was obtained at GIF++, and the experimental setup was composed of two scintillator detectors as trigger and a double gap RPC where 8 channels were considered. Signals were digitized using a CAN model. Here we can observe an analog signal obtained, orange for the CMS mixture and blue for the mixture number 3 that we will define later. As said before, mixtures are proposed to replace the actual one. In this table, we summarize the considered components of all of them. Some characteristics are shown, as well as their GWP values. From here, we can see that freon and SF6 are the components with highest GWP values. With the previous gases, blends were made and we got 5 different mixtures changing the concentration of each component, see the lower table. Freon was replaced by a mixture of HFO and CO2. The GWP of each mix was calculated. We can see an example of this calculation on the lower box, and in the table at the top, the values are summarized and we assign a code color for each one, used for the next results. The analyzed signal were those which exceed a threshold defined as 10 times the standard deviation of the offset size of the first 100 points of the signal. The efficiency was calculated as the quotient of the number of events with signal divided by the total number of events, and the working point was defined as the high voltage value at which the efficiency is 95% plus 115 volts. In the plots, we can observe a similar behavior for all mixtures, although the efficiency curve is shifted to higher high voltage values. In both single and double gap mounts, the working point is still acceptable. Mixture 3 and 4 show almost the same behavior. The difference is an increase of isobutane of 0.5%. On the other hand, increasing HFO in 5% from mixture 5 to 3 and from 3 to 2, we get an increase of the high voltage working point around 300 volts. The cluster size was defined as the number of consecutive strips with a signal above the threshold. As we see, cluster size is almost constant with a value of 2 for all mixtures except for mixture number 5. Here, we consider the probability of having a cluster size greater than 6, and we can observe for all mixtures that this probability is lower than 10%. The presented study was approved by the CMS collaboration and presented at national and international congresses. Promising mixtures have been found, thus have much lower GWP values than the CMS mixture, and mixture 3 and 4 have shown a good behavior. Efficiency was shifted to higher values, but working point is still acceptable. The cluster size remains almost constant at 2 for all mixtures, and the probability of having a cluster size greater than 6 is much lower than 10%. For future work, this blend must be validated at a cluster rate of at least 2 kHz per square centimeter. This can be done at GIF++ at CERN. A detailed study of stream probability is needed. The study of cluster size greater than 6 is only a first approach. These results were presented at the 7th Conference Large Hadron Collider Physics in 2019. And with a more detailed approach to data analysis during the 62 National Physics Congress also in 2019.